All right, so the first rule, or the only rule we're going to talk about today, is called the inverse rule. And so you guys should, I hope, be familiar with what an inverse function is, right? How do we determine what an inverse function is for another function? What do we do?
Flip it over the y equals x line.
Right, it goes flipped over the line y equals x. So you can see in this picture, we've got a function here, and then we've got its inverse, right? And they look like they're reflections of the line y equals x. So that's what an inverse is. And the way you solve algebraically to figure out what an inverse is you exchange the x and the y values in the function and then resolve for y. Everybody familiar with that? Remember that from, I don't know, 3rd or 4th grade? Something like that?
Yeah.
All right, perfect. So the rule that we're going to look at for functions that are inverses of each other is that if a function contains a point a, b, then what does its inverse contain? Or if a function contains a point ba, its inverse should contain the flip of those points, right? If one contains ab, the other contains the point ba, right? We just flip the x and the y values. Everybody's comfortable with that, I hope. Right, that's originally how you probably, like, back in 3rd grade, graphed the inverse of a function, is you just took all the points on one and flipped the x and the y values and graphed that and saw that it looks similar to it, but just flipped over the line y equals x. Another thing you might note about inverse functions is if you try to do a composition of f and its inverse, what do you get?
X.
Yeah, it always comes out to be f, right? F inverse of x. I don't know why I wrote a 0 there, but it's an x. F of f inverse of x is always x, and f inverse of f of x is also x. So all those things show that the functions are inverses of each other. So the rule that we're looking at is if these two functions are inverses, meaning that they share this relationship between points, and we're looking for f inverse is derivative at a, then it should be equal to 1 over the derivative of f at b. Okay? So here is the point AB on our inverse functions graph. And if we want to find f inverse prime of a, then we could use the original function f of x and find its derivative at b. And they should have slopes that are reciprocals of each other. Okay? Which I think should hopefully make a little bit of sense, because if I have a slope of 2/3 here, right, a reciprocal slope of 3/2 would mean that I've, instead of risen 2 and ran 3 for my slope, I would have done the opposite. I would have risen 2 and ran 3. Does that sort of make sense?
Yeah.
Okay. And so a lot of times all this notation kind of messes with people. So I'm going to write it out the way I normally write it out also. So if I say if f and g are inverses, and f contains the point AB, and that means g contains the point BA, then f prime of A is equal to 1 over g prime of B. That's the inverse rule. Everybody good with that? And why might we see that this is helpful sometimes? What do you think? Why might this be helpful sometimes?
Because the derivative of an inverse function might be a lot easier to find than that.
Right. It just depends. Like if f is really difficult to find the derivative of, but we can find the inverse of it really easily, we might be able to use that. Or if we want to find the derivative of the inverse, but we can't actually find the inverse of the function. Like there's some functions, if I gave you y equals x cubed minus x squared plus x plus 7, it's going to be very difficult to find the inverse of that function, isn't it? Exchange the x and y values and then resolve for y. That's going to be difficult. But if I know a point that they share in common, I should be able to find the derivative of the inverse at a certain value, potentially. So that's how we're going to use that. Does that make sense to everybody? Hopefully.
Yeah.
We're just gonna do a couple of them, and then I'm gonna give you guys some more practice with this. Nothing due today on it, but stuff due later in the week on it. So but you still have that implicit differentiation one due today. So let's take a look. Here is f of x equals x cubed, and g of x is the inverse of f. But we want to know g prime of 8. So one thing we could do is we could, because this is a pretty straightforward function, we could actually find the inverse of f, and that would be g of x, and then take its derivative and evaluate it at 8. And we'll do that in a minute. But I want to see if we can use the inverse rule first to figure it out. So if g of x, if we want the derivative of g of x at 8, that means that there must be some point on g where the x value is 8. Would you guys agree with that?
Yeah.
Otherwise, we can't find the derivative of g at 8. So then what can you tell me about a similar related point for f of x?
There's a y value at 8 of 8.
Right, there should be a y value of 8, right? And if we want g prime of 8, g prime of 8 should equal 1 over f prime of whatever this x value is. Right? Well, we should, since we know f of x, be able to figure out what x value gives us 8 and what x value is f8.
2.
2. So we should be able to say this is the point 2, 8. And the point on g that we're looking at is the point 8, 2. And so we want g prime of 8. It should be 1 over f prime of the corresponding x value, f prime of 2. And what's f prime of x?
3x squared.
3x squared. We evaluate that at x equals 2. What do we get?
12.
12. And so g prime of 8 ought to equal 1/12. Right? 1 over f prime of 2. Everybody good with that?
Yeah.
Yeah.
All right, cool. Now let's just make sure this is true. If f of x is equal to x cubed, we could write this as y equals x cubed. And then what do? Exchange the x and the y values, right? To get x equals y cubed, or the inverse of y equals x cubed is y equals the cube root of x. True?
Yeah.
Yeah.
So doing all that tells us that what is g prime of x equal to? Should be 1/3 x to the negative 2/3. And if I were
Yeah.
to evaluate this at 8, that should be 1 over 3 times 8 to the 2/3 power, and 8 to the 2/3 power, take the cube root of the 8 first to get 2, square it to get 4, and you get 1 over 3 times 4, or 1/12. So we can see that for this one, that we could actually do the inverse of the f of x. We can actually find that inverse. We can show that it's the same. Everybody good with that? See that it's the same?
Yeah.
Yeah.
It may not have been any easier to do it this way, and I don't care which way you do it, but there will certainly be functions where you have to use the rule, where you won't be able to explicitly find the inverse. So in this particular problem, had you done it either way, either using the rule or just by finding the inverse, that'd be okay. But make sure you know and understand the rule so that you can apply it in situations where you can't just find the inverse of it. Any questions on that?
Where'd the negative x to the negative 2/3 come from?
We had g of x as x to the 1/3, so the derivative of that is 1/3 x to the negative 2/3.
Okay.
Good or no?
Yeah.
All right, let's do another one. So we have f and g are inverses, and we want g prime of 1, and here's our f of x function. So how are we going to go about this? Any thoughts?
We do what we did before.
Okay, we do what we did before with the actual rule, right? Because if I were to write this as, y equals e to the x plus x, and then turn that into x equals e to the y plus y, solving that for y is going to be a problem. You guys would agree with that?
Yeah.
That's going to be an issue. So this is not going to be what we want to do. We don't want to do this. So if we're looking at g prime of 1, we know that means g has a point of 1 comma something, which means that f should have a point of something comma 1. And so we'll do the same thing we did before. We'll take e to the x plus x and set that equal to 1. And while that's not necessarily the easiest equation to algebraically solve, you can probably think about a couple of easy values of x you could plug in and find one that works. So what x value will work for this?
0.
0.
X equals 0 will work. Exactly. So, we got, plug in 0. E to the 0 is 1, plus 0 is still 1. So we're really looking at the point 0 comma 1 on f and the point 1 comma 0 on g. And so g prime of 1 ought to equal 1 over f prime of 0. Everybody good with that? Or no?
Yeah.
All right, and what is f prime of x? What's the derivative of e to the x plus x?
E to the x plus 1.
E to the x plus 1, and if we evaluate that at x equals 0, what do we get?
2.
We get 2, right? And so our g prime of 1 ought to be 1 over 2. Everybody good with that?
Yeah.
All right, cool. Any questions?
Nope.
All right.